Computers store different types of data, whether images, text, or numbers, using binary. But to represent these different types of information, we need different data types. In this video, we'll explore how Python handles the 4 basic data types: bool, int, float, and string. And we'll also get into the none type. Hi, I'm Oliver, a computer science student in my final year. I used to find concepts like data types and type conversion confusing, but over time, I found ways to make them click. And now I'm here to share what helped me to hopefully make it easier for you too. Now I'll be getting into how different types of information are stored in computers, or rather what types are made available to do this, but how exactly these are then stored on the computers, which is using binary, I have talked about in a previous video. In my previous video on binary numbers and binary arithmetic, I get into the specifics of how binary is stored in computers and how computations can be done on these. So I suggest you watching that video if that sounds interesting to you. And it's also useful for getting into the material I'm getting in today. So I'm gonna start off real quick with the Boolean value. Now, this is just a statement value which says whether something is true or false. So, for example, we have the Boolean true. This says that whatever we're checking, whatever this value Boolean true is storing, is true. This can, for example, be something like, is it raining today? And then this value is stored, and if we print it, which essentially just makes it end up in our terminal screen, so makes it readable for us when we execute this piece of code, we see that it returns true. And now if we get the type of this, so there is a function in Python called type, which gives us the type of the variable we're passing here, we see that the type is a Boolean. And now we can do the same for false, but now let's, instead of using a variable where we can store stuff, just use it as a literal, so meaning it is essentially just existing where it currently is placed. In our case, inside the type function, so here, this would then tell us that false also is of the type Boolean. Now, Booleans are useful for checking conditions, whether something is true or false. For example, if we return to our example, is it raining today? And we wanted to check, oh, is it not raining today? So maybe we can inverse this using, for example, the not operator. Then we get false, so it inverses this. If you have not seen my video on logic gates, I suggest you do, because this not operator actually functions exactly like the not gate. And the same can be said about and. So if we place and here, remove this and say true and true. And if we have 2 true statements and we and them, it means both of them are true and the whole thing is true. So if this does not make sense to you, what I'm doing right now, I really suggest you watch my video on logic gates, as these are super useful to know to write code, for example. But now moving on to integers. So integers, as I've written here, are whole numbers. So 1, 2, 42, negative 100, they're all whole numbers, so they are integers. Now, in computers, the storage is limited, for which reason our integers are stored with a certain amount of bits. A bit is essentially a 1 or a 0. Like I said, I suggest you watch the videos on binary numbers to understand how that works exactly. But for all intents and purposes, for this video, just assume it's any whole number. So we can have the integer 5, and then if we print it, we will just get our 5. Now, what you can also do is you can do arithmetic on this. So our variable a, which is 5 plus 2, we get our 7 out of this. And then if we check the type here, we get that it's an int, standing for integer. And just to show that it also works with negative numbers, I can, for example, negate this a. So this part here would be negative 5 plus 2, we would get negative 3. And let me not forget to remove the type here. We would get negative 3. Next, we have our floats. Floats are decimal numbers. The difference between integers is that we represent them using this dot. So this dot is what turns it into a decimal number. You can also have fractions, but I'll get to that in a second. So before we had 5, now we write 5.0. And now all of a sudden, our class is float. So you see, if I remove the 0 even, it still works. So it just tells me that there are zeros behind here. But if I don't write this dot, we see it's an int. So this dot really makes all the difference in the world. We can also see here that adding two different types, so an integer and a float, will give us, let me clear this real quick, will give us the float. So even though 2, the result of this addition, is an integer or representable as an integer, we are using a float because Python can tell, oh, the float is the more general type. So every integer can be represented as a float, but not every float can be represented as an integer. So Python generalizes and turns this into a float. And this is relevant. So type conversions in general in Python are very relevant to understand, so you know what sort of data type your function is actually returning. Since combination of different data types may result in another data type which might not be immediately visible for someone using the function or writing it. Now next we're going to go to strings. Here, for example, we can say hello, and printing it just returns it. Now what can be done as well is you can add strings to each other, and this essentially just concatenates them. So adds them to one after the other. In strings you can also add special escape characters which do specific things. This n here, for example, does a new line, so you print this across 2 lines. And there's a whole bunch of other operators that you can use on strings. Strings are the data type that has the more functionality attached to it. And here you can, for example, also use the square brackets with 2, which accesses the third character here. Now third, because in computer science we always start with 0. So we would have 0 and then 1 and then 2. So if we print this, we see there comes an L. And this is actually a list access, but lists are a bit more complicated. So strings are actually a bit less basic than the integer and floats and booleans. But I wanted to mention them here anyways, because these are some of the most used data types. Here I wrote some code to show you that these data types can be turned into other data types. So here, for example, we have a comparison. So we have the variable name, and in this print statement, we're checking whether it's equal to James. And in this case, it's John, but we're checking whether it's equal to James. The answer is no. So actually the resulting type we get here is a Boolean. And in this case, it would be false. And here I'm also printing the type, so you can see that it is in fact a bool. So here we have false and then bool. And then if we change this, for example, to James, we get that it is true now. So there is a lot of interplay with these data types, certain functionalities that automatically return them. Like for example, this equal operator returns a Boolean, and other comparative operators do this as well. So for example, greater than, smaller than, but I will not get into these. These are more relevant for logic interactions, which I might make a video on in the future. Now we're moving on to the last data type, which is the none type. Now this one just represents nothing. It's just a null type that's there in case you want to represent something as being nothing. And this is better than using a 0, because 0 still has uses. You can still add, you can subtract, do all this stuff with zeros, but we want a data type that does absolutely nothing. So that, for example, if your function is supposed to output an integer, but something goes wrong, maybe you can have it return none, so that this can be an obvious sign of something not having worked if there was an error. But just to show you that this is actually a data type by itself. So printing the type of none gives us the none type. And the none type just has this one literal. So printing it by itself, you see it's just none. Now I will just add a brief note about the type conversions. I've briefly shown this using the float and the integer. And there is also some certain functionality using strings, for example. So if I print here the string hello and I say, hey, I want to multiply this by 3. So even though this is an integer, the meaning of multiplying this with a string is not going to be outputting a integer, but rather a string. In this case, it just means, hey, please repeat the string hello 3 times. So we get hello, hello, hello. Another interesting part is the addition of Boolean to a integer. So in this case, Boolean actually in our computer represents the number 1, or is represented by 1, and false by 0. So when we say true plus 1, our result will in fact be 2. And we can also say true times 5, and our result will be 5. And then if we say false, because it is 0, it will just be 0. So you can do a lot of interesting type of combinations of data types, which will result in maybe some mess But one more important thing is the conversion of floats to integers. So by using the int function, we can turn the input into an int. And here, for example, we can use the float 0.3 or let's say 1.4. So turning this float into an integer, we're unable to represent what comes after the dot. So what happens in this case is just it gets cut off and we only have this 1. And then if we try to convert this again into a float, we no longer have this information of the 0.4 because it's lost. So now we've saved into our computer this integer, which already loses this information after the dot. And trying to convert it back into a float, we don't have access to this lost information. We just know that there's this 1, and this converted as a float is 1.0. So converting between types can make you lose relevant information, which even doesn't get replaced when you reconvert it. So that's something important to consider. Now there is a whole bunch of different other conversions and ways that these data types interact with each other, but I don't want to make this video too long and get into that too deeply. I just wanted to give a broad overview over data types that exist in computers. And the representation is a bit more complicated. So Booleans are quite straightforward. You just have ones and zeros. Well, of course, it also depends on the type of implementation you have. So how the code is compiled and what your architecture specifies. But that is a bit more complicated. Integers, you might be familiar with the technique they use if you've watched one of my videos on binary numbers. Floats are a bit more complicated, and I might make a video on this in the future if that's interesting to anyone. Strings are a list of characters, and a character, for example, is W, R, or H, or anything like that. And these are represented using encoding, for example, ASCII. Then the none, this one has one representation, essentially saying, hey, this is a none. And that is already sufficient because we don't have several different data types like true, false, or other numbers. If you enjoyed this video, you might enjoy my video on logic gates. If you enjoyed this format with Python, please drop a comment to let me know. And perhaps also tell me what sort of video you would like to see me make in the future. And don't forget to subscribe to receive notifications for new videos. Thanks for watching.